Hi everyone, today we're going to be looking at some fun integrals, and before we begin solving them, I'd like you to try them yourself. So these aren't all going to have the same solution or even the same process applied. So just try to see what works and what doesn't work and try to find a way to solve each of these. They're not in any particular order. The first one might be harder than the last one and so on. So let's get started. We'll begin with this one right here. And over here, this is like really a typical area where you might use integration by parts, because you can't really, you can't use u substitution here, and you don't see a neat trick to use right away. So when we're using integration by parts, we want to take one of these things. So we have x times natural log of x. We want to integrate one of these, and we want to differentiate one of them. So which one's going to be easier to integrate? And which, well, both of them are easy. Sorry, x is significantly easier to integrate than natural log of x. Natural log of x is x natural log of x minus x plus c, and meanwhile x is just x squared over 2 plus c. So this is definitely easier to integrate, and when you're differentiating, this will give you 1, this will give you 1 over x. So we're going to take this and we're going to integrate this one, and this is the one that we're going to differentiate. Okay, so now when we're doing this, at first we just integrate this, we get x squared over 2, and we multiply it by the natural log of x. Natural log of x. And now we subtract the integral. We still keep x squared over 2 over here, but now we take the derivative of the natural log of x. So we've got x squared over 2. What's the derivative of the natural log of x? That's 1 over x, and then obviously dx. So let's simplify this a bit. This obviously stays the same. We don't really change that yet. Now over here, what are we subtracting? Well, the x and the x squared give us x. So we get, and also we can take out the 1/2. We don't really need that inside the integral. 1/2, and now, so imagine the 1/2 is gone, this is gone, we just have x dx. Now I think you can pause the video. If you didn't get this far, that's fine. Pause the video here and definitely try to see what you get here, because this is, we're close to the finish line now. This stays the same. I'll just use quotation marks for brevity. And now all we have to do is subtract it, right? Subtract this. Now what is x dx, the integral of that? That's x squared over 2. And I'll put the plus c at the end. Trust me about that. I just don't want to write it again and again. So we have this. And now if we simplify it, what do we get? This is minus x squared over 4. And here we have x squared over 2 natural log of x. And then of course we have a plus c. So this becomes our final answer. And how did we solve this? We used integration by parts, right? That was a process that we used for this one. Now over here, you might be tempted to use a similar process. But over here, and actually that's what I thought at first as well, but then I realized that, well, we've got an x squared and we've got an x, and we can actually just use u substitution right here. Because rather than doing all this messy stuff, it might get harder. Especially, you'll have to use the chain rule to differentiate sine of x squared, but you don't want to differentiate that. You want to differentiate the x instead. So then you have to integrate this. It gets pretty messy and complicated, but luckily it's actually better that we've got an x in front over here, because what can we do here? Well, we can say u equals x squared, in which case du will equal 2x dx, right? So we've got this, and now if we isolate dx, we get dx equals what? Du over 2x, right? So let's plug this in now. Now we've got the integral of x, then we've got sine of u, and then we've got dx. But what is dx? Dx is just du over 2x. Now I'm going to do some simplifications. Don't worry about it. We're cancelling out the x's. That's the first step. Then we're taking the 2 out. It's 1 over 2. So we're making it half. And now we've got this again. Sine u and du. What is the integral of this? Well, that's negative cosine of u plus c. Negative cosine of u. I'm not going to do that directly. I'll put the negative in front. And now we've got cosine of u. What is u? U is x squared. So just cosine of x squared. And then plus c. There you have it. That's our final answer here. What did we use here? We used u sub. Right? We just used u substitution. So that was pretty easy. Now this final one, it seems like, you can't, maybe you want to do u substitution because the derivative of tan x is secant squared theta, maybe secant squared x. Maybe you can get that here, but it just doesn't work out. You can try it yourself. We need these to be multiplied ideally, in which case we can take the derivative of secant of x as, I believe, tan x secant x, but we don't have any of that here, so it looks a bit tricky. But actually, this is a very basic question. It's just that we are used to doing these harder questions here. Over here, we can literally just break it into two integrals, right? Secant x tan x dx. I'm not using the brackets here, just like again to save some space. Then here we have secant squared x dx. That's literally all there is to it. What is the antiderivative of this? That's secant x plus c. I'm not going to write the plus c, obviously. We'll be writing that here as well. And what's the antiderivative of secant squared x? That's tan x. So tan x, there you have it. And then, yeah, now we do have to put the plus c. So that's all there is to this question. Sorry, this is all there is. So this is, I'll just write basic rules. And that's all there was to that one. So these are the three questions. I thought these would be interesting to try out, especially this one, because after doing u substitution and integration by parts, maybe you try to do something like that, and the answer is right at your fingertips with this one. So I just thought this would be fun to share. Let me know if you have any questions or any other, if you have any questions about this, or if you have any other questions you'd like to ask me, any suggestions or any feedback, anything, just comment down below, and make sure to subscribe if you enjoyed this video. Thank you so much for watching. Bye.